Hello students, so today we are going to start a new topic S1.4 and the topic name is counting particles by mass, and we will talk about the mole today. This topic is important for IB examination point of view. So majorly in this small unit there are major subtopics are: first we will discuss about mole unit, then we will talk about what is molar mass, next we will talk about empirical formulae, next we will talk about the molar concentration, and at the end we will talk about Avogadro's law. Right, so let's continue with the first part, the mole unit. See, mole actually represents many things, right? First, mole represent number, right? Mole represent formula, right? So mole also represent molar mass, right? So there are so many things mole do. So let's talk about this one by one in this particular unit. So let's continue. So we are going to discuss about, first we will talk about the mole. So there is Avogadro number, the Avogadro constant, right? Avogadro constant we generally represent with Na, or sometimes also written as L, is the number of particle. When we say the Avogadro constant, it's a number of particle equivalent to the relative atomic mass or equivalent to molecular mass. Now what is Avogadro constant value is? So value is 6.02 into 10 to the power 23 mole inverse, right? So what it represent? This is equivalent to first equivalent to relative atomic mass, right? And then it is also to relative molecular mass. Fine. And Avogadro constant applies to atom, molecules and ions. Where it is applicable, it's very important. It is applicable for, we can use this Avogadro constant for atoms, molecules, ions, right? These places. So when I'm saying 1 mole, let's say 1 mole of oxygen atom, what is the mass of this particular? So mass is 16 grams, right? It's 16.01 something. I'm just writing 16 grams, right? This is the molar mass, sorry, atomic mass. Because why? This is an atomic mass. Why I'm saying atomic mass? Because this is an atom. This is oxygen, right? This is not zero. This is oxygen. And how many number of particles they have? That is 6.02 into 10 to the power 23. This is the number of particles. right? So same thing, if I'm writing 1 mole of, now this is oxygen molecule, how many mass, what will the molecular mass? So it will be 32 grams. And how many number of particles are? It will be same. This is the number of particles in this particular molecule. So 1 mole of substance contains the same number of fundamental units as there are atoms in exactly 12 gram of carbon. If you had Avogadro's number, that means, so as traditionally what we know that 1 mole, so actually this is important, this you have understood, that means things are clear. If I'm going to say 2 moles, if I'm going to make this as a 2 mole of, let's say, oxygen atom, so automatically you have to multiply 2 with the entire thing, so that will be 32 grams, and the number of particles will be 2 into 6.02 into 10 to the power 23. If I am going to say 2 moles of oxygen molecule, 2 means 32 into 2, that means 64 grams. And particles, same thing. So this is fundamental. So 1 mole of substance contain same number of fundamental unit as there are atoms in exactly 12 grams of carbon 12. And if you have this much number of particles, that is equivalent to that. So next point I can say, if you had 6.02 into 10 to the power 23 atoms of carbon 12, you would have a mass exactly 12 gram, right? So with this we can also say that so can I say that 1 mole of water, how many mass? So now there is 2 hydrogens, so 2 into mass of hydrogen is 1.01 plus oxygen is 16 gram, so this will be 18.02 gram. Did you understand? Let's take an example. Let me give you an example, it will be clear. Relax, just stick to what I'm saying. If a question is determine the number of atoms, molecules and relative mass of 1 mole of, let's say, first let's try to find out for sodium, right? So for sodium, you have the periodic table in your data booklet, so you will find relative atomic mass for the sodium is 22.99. Therefore, can I say 1 mole of sodium has a mass 22.99 gram mole inverse. And 1 mole of sodium will contain how many number of particles? So I can say 1 mole of sodium will contain 6.02 into 10 to the power 23 atoms of sodium. If let's say I have to find for, let's see a second example, hydrogen molecule, right? So the relative atomic mass is 1.01. It is given in the data booklet. Since there is a 2 atom, so 2 hydrogen atom, so mass will be 2 into 1.01, that means 2.02 gram mole inverse. And 1 mole of hydrogen contain how many molecules? That will be 6.022 into 10 to the power 23 molecules of hydrogen. And however, since there are 2 hydrogen atoms in each hydrogen of H2, so 1 mole of H2 molecule will contain 1 mole of H2 molecule contain 1.204 into 10 to the power 24 hydrogen atoms. Fine. Let's say if I am saying third question for NaCl, let's try to find out for this. So the relative atomic mass, what is that? For sodium is 22.99. This is for mass of the sodium, plus chlorine is 35.45, right? So if you add them, you will get, just have to add. So it's let me use like this: 22.99, 35.45 will get 14.5678 and 3 to 5. So answer is 58.44 gram. So therefore 1 mole of NaCl mass is 58.44 gram per mole. And 1 mole of NaCl contain how many units, formula units of NaCl? So I can say 1 mole of NaCl will contain 6.02 into 10 to the power 23 formula unit of NaCl. Since there are both sodium and chlorine atom in NaCl, so 1 mole of NaCl will contain, now there are total 2, so I can say since there is both Na and Cl in NaCl, so 1 mole of NaCl will contain 1.204 into 10 to the power 24 atoms in total. Right? So this is how you can solve the questions related to finding number of atoms or molecules or the relative mass of 1 mole. If it is a 2 mole, you multiply with 2. If it is a 3, like that. So in the next videos, we will talk about what is relative atomic mass and how we can calculate that. Stay tuned. I'm here to help you out. See you in the next video.